Okay. And we've lost someone.
I think we lost Megan.
Megan.
Oh, we did lose. Oh, no.
Looked like she had bounced out and bounced back in, was trying to get back in, but we'll go on and introduce her. Oh, when she comes back in.
Coming back.
Hi, everyone. Welcome to this space. I am your co-host, Nicole Gugliucci, postdoc with the CosmoQuest Citizen Science Project, and I'm joined by my co-host through the wall, Georgia Bracey.
Hello.
Literally through the wall.
Yes, actually. Other side of the wall.
Other side of the wall. And we are joined by Kimberly Arkand from the Chandra X-Ray Center. Hello, Kimberly. And Megan. Megan, how do you pronounce your last name? Sorry. Having connection issues.
Okay.
Megan has a gorgeous outdoor spot that she's broadcasting from, but unfortunately outdoor spots don't always have good Wi-Fi.
Oh, yeah. It keeps kicking me off for some reason.
Yeah. Hi, Megan.
Hi, sorry about that.
So if you are watching, we'd like for you to participate by using the Q&A app. If you are watching this somewhere and there's a little Q&A app button wherever it's embedded in the YouTube videos embedded or on Google+, click that to join the Q&A app. You can send us questions, comments, hellos. We got a hello from Nancy Graziano. Yay! We're going to be seeing in about a week in Balticon, Baltimore for Balticon, so very excited. So we are here to talk some about different types of education outreach coming out of the Chandra X-Ray Center. For those of you who don't know, Chandra is a really super awesome X-ray telescope that is a satellite. It has to get away from the Earth's atmosphere because the atmosphere very helpfully protects us from X-ray radiation. However, that isn't helpful if you're an X-ray astronomer. So it has been, and it's one of the most gorgeous imaging space telescopes that we have, which is kind of a first for X-ray. We still joke with our X-ray astronomer friends about them counting photons or writing papers on one or two very energetic photons, but Chandra actually sends back some really gorgeous imagery in the X-ray. So I would first like to hear from both of you guys a little bit about you, what's your background, and then we'll get into some of the work. So Kimberly, do you want to start?
Sure. Thanks for having us. It's kind of fun to be doing this, something a little different. So my name is Kim, and I've been working for Chandra for about 16 years, I think, so it's been a while. And Chandra is really cool, as Nicole mentioned. It gets to look at really amazing things. So part of my job is just to help tell the stories about the Chandra science. Most of the work that I do is like a visual component, so I get to work on the process of image creation and then what to do with those images, which I think is really important. My background is pretty eclectic. I actually started out with my undergraduate work in biology. I was doing parasitology, so I was studying things really, really tiny. Then I moved into computer science, and then I eventually went to study public humanities as a way of figuring out how to communicate science topics.
Awesome.
Awesome. Very cool. Megan? Are you frozen?
I
believe she's frozen. Okay. So I guess she'll cycle out and try again. So I was drawn to the work you guys have been doing with the Chandra blog. Keeping up a blog is a significant task, I think, but it's a really great education and outreach tool. But you guys are using the blog and social media to put out so much amazing stuff. Can you talk a little bit about how the blog got started?
Sure, yeah. So we have kind of a small core group of folks who work in the public engagement and communications section of what Chandra does. And kind of our whole methodology is to work really closely with the scientist whose result it is, and then work on being able to publicize and contextualize those results in a way that'll be meaningful for other people. So we're big into recycling because we don't have like a huge team to do lots of different kinds of work. So I think we kind of use like a pipeline methodology, if you will, where we'll get a new science result and we'll work on that. And Megan is the press officer, and she will, work with NASA to make sure the press release that goes out is great and it's, wonderful. And then it's up to us to figure out other ways to get that information, to reuse that information in ways that'll be useful. And the blog started up as a way to just be a little bit more, being able to contextualize, I think, a little bit more, being able to put things there that are interesting but not necessarily a press release, maybe something about the telescope itself as a place to talk about the team members of the Chandra X-ray Center and the work that the engineers and the software developers do. We've done things like highlighted different kinds of science and how it all relates back to Chandra. We've also looked at women in science and what their specific contributions are. So we kind of looked at the blog as a way to, bring all this different types of information to our audiences in a way that would be sort of interesting, that they could subscribe to, that they could comment on, that they could make it useful for them. And I think it looks like Megan has popped back on. So.
Hi, Megan.
Hi, sorry, I don't know what's going on with my system. It's my technical difficulties.
Yeah,
I'm sorry the lighting's so dark. That's why I was actually outside, because there's not great lighting in my office.
Sure.
So, anyhow, sorry about that.
That's fine. That's fine.
I know,
Do you
I
want
hear
to
you.
give you
That's
background,
good.
and we were just getting into the formation of the Chandra blog.
Okay. Do you want me to jump back and do my background and all that?
Yeah.
Okay.
Yeah.
Yeah, so my background's a little more, I would say traditional is the wrong word, but I went to my undergraduate degree, I got from the University of Michigan, and I do have a degree in astrophysics. I was always interested in the subject, but wasn't quite sure what to do with it. So I did get the degree, but then I never used it in a traditional sense, because right from undergraduate I went to a master's program in science journalism at Boston University. So from there, I became the public affairs specialist at the Center for Astrophysics, where Chandra is located. And then about a year after Chandra launched, I was asked to come on board and become the press officer for Chandra. So, and I've been doing that ever since 2000. Kim and I collectively, I think, have 30-something years there. Which is scary. Yeah, I know. So yeah, and so it's, Kim and I have worked together for a long, long time, and we always kind of joke that we're, two halves of the same brain sometimes, but it's a lot of fun. I do more of the words, not the visuals that Kim is so good at. So that's a very rough breakdown of what we do, but that's it helps a lot to have my other half.
Cool.
Same here.
Kim, can you tell us about the visuals? What does it take to bring this X-ray data to a format that people really understand? I mean, the composites are so gorgeous.
Yeah, I mean, that's probably one of my favorite questions, and I could probably talk for a good hour just on that, and I do talk for hours on just that. But I think what's really interesting about the process of visualization for us is that, it's not like taking your phone and holding it up and taking a selfie. There's a lot of steps involved in the process of obtaining data from this amazing spacecraft that's way out there, a third of the way to the moon at maximum, and transmitting it back to Earth, turning those ones and zeros that have no inherent color, for example, translating them into a visual representation of the object, and then adding color and adding additional information. And as you're seeing on this screen, one of our sort of mottos is to contextualize whenever we can. And a lot of the times we have to add additional data from other wavelengths. So not just looking at an object in X-ray light, but looking at it in infrared or optical or radio to help tell the story. Sometimes if you look at an X-ray image, it can seem a bit esoteric. It could look a bit nebulous or blobby, if you will. Very loving terms for me, by the way. I love Chandra blobs. And if you look at just the X-ray image alone, you don't always necessarily get the sense that this is a cosmic object. So we will often use something like an optical star field or additional radio data or other multi-wavelength imagery to help the image so that, for one, you have a little bit more of a recognizable object to look at. You're immediately using somebody's knowledge base if you have something that is a little bit recognizable. But of course, the other side of that is we're not just adding data to make it pretty. Like, we're actually trying to help the story. We're always trying to, by adding additional wavelengths or by adding color, we're trying to essentially increase the informational quotient of the image. So it's a long process, but it's fun, and we've come up with some really cool ways to look at it. And part of our work is actually figuring out how people respond to the images. So it's not just figuring out how to make an image that looks good, but also when a non-expert or an expert look at that image, what will he or she actually see? What questions will be in their minds? What misconceptions will pop out based on how they're looking at it? So we try to take all of that into consideration when we're working on the visuals.
I imagine the blog might be kind of helpful to get that information to you. So I bet you have a lot of interesting response to the different things that you're showing on the blog.
We do, actually.
Feedback, yeah.
Exactly. We actually even have, it's called Chandra Data Behind the Scenes. There's a little, like, a subcategory of the Chandra blog where our image processor, Joe DePasquale, he actually gets a little bit into the nitty-gritty of how images are created. We talk about what we do with, like, the metadata of an image and how we make it. And then we also get good comments from people all the time. We also have a comment system on the image release pages themselves, and we'll get additional comments from people there. And we've run a study that's called Aesthetics in Astronomy. I can give you the URL later if you're interested. But it's a research project where we actually, do online and in-person based studies for this type of imagery, so we can really get into the details of how experts and non-experts look at this stuff.
Oh, that's pretty fascinating.
How many puns can you make from FITS? FITS is the image type, the file type that is commonly used in astronomy, and right on the front page of this Chandra Data Behind the Scenes, there are 2 FITS puns.
We love our data.
That's fantastic. I'm a blobby person myself. I started in radio astronomy, so I get what you say when you say you love the blobby bits, but that's not easily communicable to the public, I think.
Exactly. I mean, you think of an image of a planet, and that's pretty recognizable. Or you think of an image of a galaxy, for example, an optical, and you can kind of see it and you think, all right, that's an astronomical object. But if you look at, like, I'm trying to think, the Tycho supernova remnant, for example, and you look at that, just the X-ray only, it's a gorgeous, deep image of that object, and it's beautiful in its own right. But without context, we've actually had plenty of people think that it's a biological image. It looks like something you might see under a microscope or something, So, and there's nothing wrong with that, but just by simply adding an optical field, you can immediately say, all right, I'm looking at an image of space here. So we just try to take things like that into consideration.
Yeah, that's not a virus.
Yes, right, that image, exactly, yes.
Not a virus.
Not a virus, yes.
And that one looks like a combination as well of X-ray. There's an optical backfield. Is there radio in this as well? I'm not sure.
No, I believe it's just the way we cut the colors. But
oh, freaking cool.
Tycho is one of the images that objects rather that Chandra has looked at a lot, and that is just X-ray and optical. But you're looking at the high energy X-rays in blue, and that's where you're seeing those little bit of streaks, and then the lower and medium energy X-rays in red. So
that's impressive.
Yeah, it's a cool one, but it does look very biological.
Yeah.
Oops, I'm still screen sharing. Okay. So when you profile people on the blog, can you tell us a little bit about how the scientists react to that, or what kind of stories you get from them?
Sure, yeah. So, we started maybe in the past year and a bit having the researchers, the principal investigators of the data who we're doing a release on, submit their own perspective and their own blogs. Maybe it's been a little over a year, based on their results. So kind of some of the stories behind how they got to where they are, or some of the stories just behind that specific science topic. But it's pretty eclectic, and what we were able to do, when you're writing a press release, and Megan is back, so she could probably talk more to this, is that you can only fit so much into the press release. So having the researcher or the scientist, the principal investigator, whatever you might want to call him or her, being able to write the blog, in addition, you get a lot more detail. You're also getting that sort of personal perspective, which can be really interesting. Like some of the women scientists that we featured, it's really interesting to see, how they've gotten into their research and what they're doing, and it just gives you more information than you can have if you only see the press release. Sure. Megan, I'll hand it over to you.
Yeah, I've dumped one browser that won't be named, and hope that that's what the problem is. I don't know why it keeps dropping me. Anyhow,
could be browser, could be connection. If you have a wired connection, you'll be more stable that way.
Okay, well, it's driving me nuts. But anyhow, I apologize. Yeah, the press releases are very, especially working for an agency like NASA, who has they have very specific ideas about what they want in their releases, and they don't want them to be too long. So in order to get any additional information kind of that doesn't fit that sort of standard of the press release, the blog's been very useful to have, because there's no space limit, and we've been really happy with the amount of participation we've been getting from the scientists who are involved, and they've been really giving of their time and energy to write these extra perspectives.
What?
Oh no.
I'm back.
You're duplicated.
I don't know what's going on.
Fine, we didn't miss anything. I don't think.
It's driving me crazy. Anyhow, so yes, the blog has been a great outlet, and it was one of our scientists who works in our group, Peter Edmonds, who came up with the idea to invite the PIs to do this, and it's been, I think, very successful in a way to enhance our press releases and the other outreach we do.
Very cool, very cool. You guys are also involved in the Carnival Space, which is another outlet way. Can you tell us what got you involved with that?
Gosh, I think, we had seen an email from, I think it was Fraser Kane, who had originally started it, and this is going way back. I don't remember, we've been doing it for a number of years, and it looked just like something fun to do. We had only had the blog for maybe 6-8 months at the time, and, we weren't really sure how our user base was really going to grow, so we thought the Carnival of Space would be a great way to sort of see if we can just expand the audience a little more. And I don't have any sort of definitive correlations in our stats, but our blog has very successfully grown over the past few years, and we definitely do see linkages from the Carnival of Space entries. So, I mean, what it is, it's a nice way to just summarize some of the interesting results that are coming out in astronomy each week, and it's kind of fun to break that down and to publicize those little bits and pieces too. So, but I do think it's helped grow our blog a little bit as well.
Yeah, how much do you know about your readers? Because obviously you're getting more and more of them, but do you have a sense of who they are, which groups are reading?
Yeah, those are great questions. We do a lot of evaluation for Chandra for sure, but we haven't done a specific slice of just the blog readers. We know that we have about 80,000 users registered for the blog, but we also know that a lot of people use like junk emails to register. They don't necessarily want to be something that is continuous. The active user base is much, much smaller. And we also know that, from doing surveys of our entire web presence as well as our social media presence, we've been able to learn about them, and we also do focus groups and surveys of all of our audiences. So we kind of try to have a bigger picture perspective of who, what, where, when sort of thing.
Right. That's really great, yeah.
Yeah, and seeing the growth over time with the blog, and continuing just to have good comments and ratings in the blog and whatever. It's such an easy thing to add. It's not, the blog is not a major undertaking in itself. As I mentioned at the beginning, we have this sort of pipeline that the science results drive, and we sort of splice out the various needs from there. So the press release goes out, or the image release goes out, and we have that official press release, or we have a smaller image release on the website with additional information on the images and background information. Then it goes to the blog, it goes to podcast form, it goes to social media. So we try to reach folks in as many locations where they'll be, instead of thinking that, oh, they'll just come to our website or they'll just come to us.
Right, right. Now, do you get to be involved in doing any of that evaluation, like the focus groups? So I imagine that would be really interesting, and so that part of what you get to do also.
It is actually. I'd say maybe research, including evaluation, is about a quarter of what I do, and I actually like that part a lot. I really like focus groups. I love being able to sit down in a room with people who have volunteered their time to help make your stuff better. I find that incredible. Of course, I'm also one of those people that will take every survey that anybody emails me, hands me on a little piece of paper or anything, because I know how valuable that information is. So just my, plug for the day. Take the surveys.
I know, it's true. Yeah. They are really important.
We have one coming out soon.
Yay, surveys. Yep.
Yeah, I'm looking at this the post. What makes an astronomical image beautiful? Can you talk more about maybe what that paper found in terms of? I mean, this is an actual research paper or study of some sort on what people find beautiful about astronomical images.
Yeah, that post, actually, I really like that post. So our press scientist, Peter Edmonds, he's really, really heavily involved with all of this, and he wrote this blog post because he had seen an article come out in the Communicating Astronomy with the Public journal, and it was similar to some of the work that we do with Chandra called the Aesthetics in Astronomy Project. And sort of the whole idea of it is just figuring out first what makes an image tick. So what are the sort of mechanics of getting a very aesthetic image? And this article, this blog post from Peter, sort of details some of those elements. Talking about whether it's dynamic range and the stretch of an image to the full composite. And he also really did fold in the aesthetics and astronomy research as well, just based on, one of the interesting things that we found in our research, and this was something that was surprising for me, was that if you have two versions of an image, say a galaxy, and you show one in red and one in blue, and they're both, very pretty, and you're interested to see, is there a preference for either one of those images? Well, we found that there was no preference for the images when you didn't have any text. But as soon as you added text, the aesthetic value or the preference of those images actually went up. So what we're able to learn is that, you can't really separate form from function, I guess is what I'm trying to say. I always sort of thought you could, and I guess in a way you can. You can still go to an art gallery and stick an astronomy image and appreciate it if there's no little tags to go with it or something. But what was so useful to learn is that the aesthetic appreciation of an image went up in all cases when you had a caption that helped you understand what it was. So it's just that idea that you can make an image beautiful, but what does it mean? And that's sort of the true value of the image.
Cool.
Yeah, I mean, just to add to that, I think that we have, being an X-ray mission, we, there is no traditional RGB color scheme necessarily. You can use that for low, medium, high, and a lot of telescopes do that, and that's a totally valid way to go. But because we aren't tied to that palette, we often have images that are in different colors and color schemes, and we wanted to know what were we communicating when we did that? Were we confusing people? Was it causing misrepresentations? And what we found, or Kim has found really with this project, is that no, we're not. As long as you're very upfront with what is in that image and what each layer represents, you really have the whatever the whole box of crayons can be opened, so to speak. We don't use crayons, but it's really much wider than what you can imagine just using that traditional format, and it's okay as long as you are clear about that.
Okay. I'm taking mental notes for the radio astronomy stuff, just so you know.
Oh. Great.
But I just one more plug for aesthetics and astronomy, if I can.
Yeah.
So Kim started this group. I don't know, what year was it, Kim?
2008, I think.
Okay. And it's a unique group in that there are obviously astronomy people and a couple astrophysicists, people like Kim who are astronomy communication professionals, but also there are two professors from the University of Otago in New Zealand who are aesthetics. That's their field. They're psychology professors. They don't have any astronomy connection per se. So it's a unique blend of expertise to look at this one very important question, which is how do we process
Ah.
Oh.
We lost her again.
Come on,
Well,
other half of the brain.
I guess I could finish, how do we process these images to make them the most useful for our audiences? And I could just add a tiny plug here that we're actually about to release a new online survey for aesthetics and astronomy to find out some new things. So I can circulate that URL. It's about to go live any day now. And we're really excited to get new data to help us analyze and figure out, not only what makes an image tick, but why people respond to these images and what they think of them and what value they take away from them.
And this is at astroart.cfa.harvard.edu.
Exactly.
I just shared that link out in the event pages, so you guys can follow that. I'm going to go do my research on that after we're done. We have a couple comments. One from Guido. Hi, Guido. Guido Bibra in Germany. Talking about the Tycho's supernova remnant from before. I think it may be a form of pareidolia, depending on what you've seen before. Everything round shape equals biological, not for everybody, but for some people. That may be the case. It does kind of look like a cell.
Okay, I love that idea. We actually wrote a little article on pareidolia for, gosh, I guess it was the Huffington Post. Just the idea, if you look at some of the very recognizable Chandra images, a couple of them are very interesting shape-wise. There's one that was nicknamed the Hand of God, and that's
I remember that one.
PSR B1509. And I mean, if you look at it, it is interesting because it really does look like a hand. And the whole idea behind that is that our minds, our eyesight, everything evolved over time to be able to recognize faces and people. If you're seeing something in your toast, it's not because you're crazy, it's just because the way your mind works, it's meant to find these patterns and find these shapes. And it just so happens that astronomy images are like a gold mine for being able to find patterns and shapes. It's just like that cloud game, I spy something in the clouds, and that you can play with your kids on a beautiful sunny day by the ocean. It's kind of a fun way to see what your brain will do when it looks at an image.
Yeah, so that's the hand. We have several other instances of pareidolia that our friends use. One of the virtual star party astronomers has a particular nebula that looks like a hand giving you the finger. Profile picture. And of course, those of you who know Astropixie, she has been collecting dirty astronomy pictures on her blog, which Phil Plait often gives talks about in safe for work and not safe for work content.
Yeah. So they're pretty funny, yeah.
Pareidolia abounds. Absolutely. And we also have a comment from Falconio Kronos, everybody from the Hangoutathon. I have M12 from the Hubble Space Telescope as my desktop image at work. People find it pretty, but keep on asking me if they are Christmas lights. So that sounds like an excellent opportunity for some informal education.
I know, for science communication. Right.
Yeah. I think I vaguely have an idea what image that is.
M12, it's not a globular cluster?
That's what I'm thinking, globular cluster, yeah.
Yeah, I think it is, yeah.
Sorry.
Like balls of lights, they do, yeah.
Yes.
Like a tangled up mess of Christmas tree lights.
I never thought of it that way.
Right?
Yeah, that's true. And Nancy Graziano points out that the human mind's ability to see recognizable patterns is one of the reasons why so many citizen science projects work so well. Absolutely. The computer algorithms don't do as well with the shape recognition bit that our brains do. So that's what we do at CosmoQuest is recruit citizen scientists to do that work. I had another question. Oh, about what kind of skill level, reading level do you guys aim the blog at?
For our blog, probably a high school level, I'd say, for some of it. I think that's what we would say the majority of it is. We have, one of the things we do try to do is have sections of our website that students and kids can specifically go to. So, for example, when I talked about our pipeline that sort of feeds out to various audiences and various types of media and locations, we often do a kids version of the press release, for example, and we've partnered with the UNIWE project, Space Scoop, to do that.
Yeah.
I love that project. It's really fun, and I find it's really useful. You know, it's not just for small kids. Like, it's a way to talk about the science it's slightly more unique in that it's a little bit more big picture. And it's not talking down to you or anything like that, but it talks about it in a very clear, concise way, and it's often fun. And we liked those so much that we actually started turning the Space Scoop stories into Space Scoop podcasts. So we'll have like one podcast for every press release that comes out that'll be kind of based on the descriptive text of it, and then we'll often have a second one that's for kids, but I like the one for kids just as much as I like the one that's for anyone. So
yeah, I love that project because it's
great program.
It's not talking down to kids, which still too many people in science may do. But it's just changing the language in a way that is more understandable for kids.
Exactly, and it's making less assumptions. Less assumptions of what the knowledge base of the person might already have. So it might just expand terms more and that sort of thing, and adds more contextual information, all of which are good for everybody. So
it's a nice example of how to do it well. Communication. And do you guys have any other set of guidelines that you give to your scientists who would write, or like a guest blogger? Do you have any sort of?
For the guest bloggers, we keep it pretty casual. We don't really write super, strict guidelines for them, but we'll just loosely say, just talk to us like you're talking to your neighbor, like you're not necessarily talking to another scientist, and tell us something interesting about the science that didn't get into the press release, or something interesting about you that makes the story even better and more personable. And that sort of angle, it seems to grab them, and we've had pretty good success with that. So
yeah.
So you guys put out a lot of content with the blog and social media, and it is not easy to do over a long period of time, especially. What keeps you, you have a store of Chandra images, but it's not like it's always coming out with a new image every day. How do you guys keep the content coming?
Yeah, that's a great question. And we do have an image that comes out about every 2 weeks. We try to stay on a pretty good schedule for that, so that we always have something fresh coming in. But social media is all day, every day, right? So how do you do that? Well, fortunately, for being in space for 15 years, we actually have a pretty huge amount of information to work with. But I really have to give credit to the whole multimedia team that works for Chandra. Melissa Weiss, she actually does a lot of the social media on Twitter and Facebook and Pinterest, and we also have Karen, who does posts to Vimeo and YouTube, and we're just about to start an Instagram account, and so we have a lot, because it's interesting to see what your audience will do in these new places with your stuff. That's, for me, part of the draw of social media. It's not just broadcasting it with your megaphone, but like, what will people make of this, and what will they do with it? And I really like to see that. But having people dedicated to help do that with you is really important. Because you can't do all things every day. So having someone on video, and someone on social media, and someone on images, and that sort of project creation pipeline, if you will, is really important. And I think they do a really good job. Fortunately, we do get a lot of input from our scientists as well. Peter Edmonds, who we mentioned before, and also Wallace Tucker, who's another scientist who's worked with us for a really long time. And we'll get little bits and pieces. And if we have specific questions, they'll help us find answers and that sort of thing. And there's so much information on the Chandra website. If you go to chandra.si.edu, we are able to pull out sort of the interesting bits and pieces, and hopefully make that relevant for new audiences on social media.
Cool. Yeah, I can't stress this enough. Like, social media, when you do it right, it's a job. It's legitimately a lot of work.
It's a full-time job.
And you guys do it well. So if you're not following them on all the platforms, do. I totally, when I'm completely drained of ideas for when I'm doing stuff for CosmoQuest, I think, what is Chandra doing? I'll retweet one of their pretty pictures, because I know you guys always have good stuff to share.
I hope Mela's watching this and she gets to hear that. If not, I'll make sure she watches the recording. So, but thank you. It's so nice to hear.
Yeah, definitely helpful. It's like, I don't know what to, pretty, retweet. Everybody go look at that.
I love the retweet.
I
Yep.
love the retweet button. It's totally helpful. Oh, sorry.
Ooh. So I see on here you've got you've got some poetry from inspired by Chandra releases. Are you involved in that a little bit? Can you tell us?
Not directly, but we were approached by someone. Gosh, I want to say this was maybe 3 years ago, or is it 2 years ago? They had done like a competition, if you will, at their university, and just sort of passed it on to us, like, oh, isn't this kind of cool? And well, we loved it. You know, I'm a big fan of turning STEM into STEAM, or science, technology, engineering, and math. Science, technology, engineering, art, and math. I like that idea of being able to broaden, this idea of two cultures, science is over here, art and humanities are over here. It doesn't really make a lot of sense to me. And fortunately, I think a lot of people in my group sort of have a similar mindset. So we just try to be a little bit open in our approach to stuff, and if something cool comes along and we like it, then we try to have fun with it. I mean, it's just something different to try, and you never know what angle or what avenue is going to attract someone new to go ahead and learn about something in a different way, or to take information that you've provided and to sort of synthesize it in a totally unexpected way. I just find that completely inspiring.
Yeah, it's really true. I mean, you never know, and so it's great to have so many different aspects of the site, of the blog, the ways to show the data and involve people in the data and what Chandra's doing. So, yeah, I thought the poetry was really kind of a cool thing
kind
too.
Of fun. When I think Megan's back, oh great!
Yeah.
I can stop talking now.
Well, is she frozen?
Or maybe she's not back. Okay.
Like, I look for the blinking. Blinking. There's no blinking. So I've been focusing on the blog and the social media. There's a lot of EPO going on around Chandra, and there's a lot going on the site. Do you want to tell us a little bit more about your favorite parts?
Oh gosh, let me see. Well, all right, so digitally, I guess, with our website, I'd say probably one of my favorite things goes back to the aesthetics and astronomy projects. If you go to any of our image releases, we always have what we call the interactive image, and I think Nicole showed an example of that earlier with one of our supernova remnants. The idea that you can click through, it's like a Build-A-Bear. Have you ever been to a Build-A-Bear workshop when you're building the pieces? It's like Build-A-Bear for astronomy images, and you get to see it. And the whole idea about that is, for me, it's transparency. We're not trying to trick people. We're not trying to hide anything. We're not trying to make Chandra data look any better than it should be. It's the whole idea of just being really open with the process of creation, with the process of explanation, and trying to be helpful with that. So that's probably one of my favorite things that I like about the website. And I also really like the podcasts because they just tell the story in a more creative way. April Hobart is our video producer, and she does a lot of the podcasts, and Joe, our image processor, does podcasts now too. And between the two of them, they come up with some really fun things. We've actually started a new project called Here, There, and Everywhere. It's linked off of the top of the Chandra website. And the whole idea of that project is to take some of these things that Chandra has learned and help you place it in a more bigger picture type of environment. Sometimes you can get the feeling that science is very isolated, that something that's happening when you read about an astrophysics result has absolutely no relation or bearing to you. But it's not really the case. It might not be a direct impact per se of this X amount of astrophysics release is going to lead to this happening to me tomorrow. That's probably not the case. But there are similarities with things that we're observing in space and things that we get to see around us every day. So, for example, if you want to talk about things like electric discharge or atomic collisions, the sort of bigger picture stuff, if you talk about atomic collisions and you show an image of a neon sign at a diner, and then you show an aurora image, that you've seen, perhaps the northern lights, you can actually connect that pretty simply to the same process that's going on in a supernova remnant. So, the whole idea of the project is to just sort of make the science a little bit more accessible and to sort of, take it out of its little jail cell and try to, show that bigger picture stuff. So that's been a really fun part of Chandra, the education and public engagement work that we've been doing is working on that. Probably the only other thing I would just give a quick plug for is the From Earth to the Universe and subsequent projects that we've done in a similar way. What we've done is taken images from Chandra, but lots of other telescopes, observatories, and astrophotographers, and put them in places where the public will see them in an everyday situation. So perhaps at a mall, at a park, at a prison. Hopefully that's not the everyday, but it is the everyday for some. And hospitals, cafes, gallery spaces, that sort of thing. So again, trying to take astronomy and astrophysics out of its little jail cell and putting it a little bit more where somebody can approach it in a more everyday manner. So that's been fun.
You see, there's also some formal education stuff. So if you go to the education tab, we have some educators, teachers who listen as well. So you've got classroom activities. I would bet that most of those have made their way into NASA Wavelength by now. We've been promoting that a whole bunch because all the NASA things now land in one website. But if you're looking specifically for X-ray stuff, there's some really cool activities. I think, actually, you guys have some really cool supernova activities I've used for informal education before.
Yeah, actually, there's a lot of fun stuff. I do like supernova remnants. They're one of my favorite objects, I'll be honest. I'm biased towards them. And we have some really fun activities for the classroom. And then also over on the Here, There, and Everywhere website, we have some very simple demonstrations that you can do in a classroom setting or in a more informal setting, library setting, for example. We've been doing a lot of them. Really simple stuff with things like lensing, simple demonstrations for shadows, wind, for example. What I really like about the Here, There, and Everywhere activities has been that it's very easy to connect it to school curricula. So, for example, I gave a presentation in my daughter's second grade class, I think it was last week, and it was wind and weather, because that's what they were talking about, and I'm like, well, how can I connect Chandra to that? Well, pretty easily, actually. Here we go. So Here, There, and Everywhere has sort of helped us get into those interesting places where they might be learning about science somewhere like in the classroom, but to bring in a little bit of Chandra to connect it to something they're already learning is kind of fun for us. So.
Okay, I've just shared the Here, There, Everywhere site because I saw this on the Carnival of Space.
Oh, yeah.
About this exhibit being put out, so that's
yep.
Cool. So yeah, I'm just looking at the exhibits. Yeah, all over the country, it seems.
Yeah, those are mostly going, the exhibits, we have one exhibit that's circulating to libraries around the country, and then we also have a few other sections where you can make your own exhibit. You can download like open source images and put them up anywhere, and we have like small posters that you can print out yourself on a local printer and post up. And then we have all the activities to go with it to sort of expand on the content from just visual and textual to be a little bit more hands-on. So it's a fun project. It's one of my babies right now. So I'm happy that you're giving it a plug.
Yeah, because like you said, that the same physical processes that we happen in our everyday life, like light getting bent, right? That has to do with your glasses prescription, and it has to do with galaxy clusters and like dark matter.
Yeah, exactly. Yeah.
The smallest things to the biggest things.
Wind, electric discharge, the shape of speed, pillars of erosion, I mean, all that stuff. There's lots of sort of general science topics that you can connect with things that you're seeing every day, with the much larger phenomena happening in outer space.
We have a question from Hugo Burnham about the Chandra X-ray Observatory itself. It's been with us for so long it appears almost ageless, like that. How long Chandra's still producing science? How long do you think it'll last?
Well, I hope it keeps going and going. As the next X-ray observatory that would hopefully replace Chandra is, I'm not sure when we'll see that based on budgets and other issues. So I hope that Chandra goes for a long time, and I'm not just saying that because I work for Chandra, because I am really still in love with the spacecraft itself. I mean, it is an absolute marvel of engineering and technology. The folks who built all the pieces of it, down from the physical modules itself to the software that talks to it, it's truly an amazing feat. and it's doing really well. I mean, that's one thing that even when little issues come up, the software engineers and the spacecraft engineers are able to correct things from the ground, which is great because we can't visit Chandra, too far away. And hopefully it'll keep going. I know we're supposed to be going for at least 20 years. Hopefully we'll go longer than that. Who knows? But we'll see.
Yeah, that was a big open question when I was at grad school, was what's the next X-ray? It's very frustrated X-ray astronomers at my university talking about the next X-ray telescope because it kept getting pushed back and kept getting cut and kept getting pushed back. So it's really good that Chandra's lived for so long.
It is really good. And as we've seen, Hubble's had a nice long life, so hopefully Chandra will follow in its footsteps. And hopefully by the time Chandra's ready to retire, we'll have, you know, figured out the next big piece for X-ray astronomy, whether that's a smaller instrument on the International Space Station or whether it's a full-on, you know, high-resolution imaging telescope. Who knows?
Right.
Yeah, I would miss the high-resolution part because, like I said, that's pretty impressive.
The images are awesome.
X-ray astronomy, yeah, it's like it used to be like dots. It used to be like here's a pixel, here's a photon.
Yeah. And that's actually one of the really cool things about Chandra's age, is that, you know, because Chandra has been orbiting for so long, it has built up some pretty deep observations of quite a number of objects. So we saw Tycho earlier, and that's a pretty deep observation. I mean, for an X-ray telescope, it takes a lot longer to get its observations than something like the Hubble. Hubble can take shorter snapshots, if you will. It's not a great term, but you know what I mean, of an object and get a pretty good amount of resolution in a short amount of time. That's not the case for something high energy like Chandra and other high energy telescopes. So the fact that Chandra's been orbiting for so long, we actually get to look at an object like Cas A, for example, another supernova remnant, and the detail in that image is just incredible. And you know, you can't get that if you're only looking at it for like 5 hours. It takes a lot of hours to get that detail.
I'm going to pull that up because Cas A is one of my favorite objects.
Me too.
Again, from the radio side, it's like one of the first ones
Really?
that we ever detected.
Yeah, Cas A in radio is also really beautiful. And one of the interesting things we did actually with Cassiopeia A is to take a couple different data sets. Tracy Delaney, who was at MIT at the time, figured out how to use some new 3D astronomical imaging software called Astronomical Medicine, I think is the name of the software these days, and she was able to create a 3D representation of the data. And that was really incredible, you know, to be able to take that 3D model that she created and see an exploded star from all angles is really fascinating. You can learn so much, you know, new stuff from that. And then to take it one step further, we worked with the Smithsonian to create like a printable model, so you can actually, and a free model, so you can actually go on the Smithsonian's website, and I think there's a link from the page that you were on, the 2013 page. You can go and you can actually work with the 3D representation right in your browser, and there's a printable version, so you can print it out in 3D and hold a dead star in your hands. Yeah.
Oh, that's the next model we need to make. Wow.
That'd be really cool.
Is this the one? Oh, that's so pretty.
Yep, that's the one. So that's the data, plus we use some optical data and some infrared data to be able to create the 3D model. And I think if you scroll down a little further on the page, you might see it looks a little bit brain-like because it uses medical software, an adaptation of medical software. Yep, that's the image.
Hey.
And so you can actually, you know,
Gosh, there's instructions. I'm gonna.
Yep, you can turn it around exactly. Yep.
Whoa.
Yeah.
Okay, well, I missed. What are the colors? Are those the different themes of the
So
colors?
those are the different kinds of, let me see, so everything I think was mostly chemical composition. So the blue was the iron and the silicon, if I'm not mistaken. Red was infrared data, so the blue was X-ray and the green was X-ray. Red was from infrared and the yellow was optical, if I'm calling that correctly. But don't quote me on that. You'd have to go look at the color coding. But I think that's what we decided on. Yeah, there we are.
There are those jets.
And inside is the neutron star, that little bit of white jets, the counter jets. I mean, there's a lot to see in something like this. And, you know, it's really hard to look at something in 3 dimensions. You have to get the velocity data. You have to have a lot of data.
Yeah.
And is something that Chandra has looked at a lot, as well as a number of other telescopes. I think we had optical data from, oh, I'm blanking, MDM maybe, and then infrared data from Spitzer and one other kind of data. And then, you know, with all that data, we're able to create that model. So it's pretty neat.
I'm gonna share that link. 3D
Okay.
Cassay.
That's another pet
Excited.
of mine.
You just made my day.
Alright.
But I'm biased. I don't know. Or my other favorite Chandra photo is, of course, of the bullet cluster.
Oh, yes.
Because that was the moment when dark matter dropped the mic and walked off stage. Right?
Never heard it described like that before, but I do like that, yes.
It's kind of like, there you go. Particles, do it. But that's a combination of the Chandra, which is the gas, the hot gas in the bullet cluster. And now there are multiple examples of these colliding galaxies, galaxy clusters. And then the blue mass was figured out using microlensing data in the optical. And so that was parts of the supernova, I'm stuck on supernova, parts of the galaxy cluster that went through and parts that did not, showing that the dark matter is indeed moving away from the hot gas. So.
Exactly. That image is one of my favorites too. And you know, stuff like dark matter and dark energy, those can be really hard concepts to talk about. So that's another area that we sort of had to get playful with how we talked about those types of things. And one of the things that we actually worked on was, we call it the jelly bean universe. And if you Google that, you'll see that. But essentially, it's a jelly bean jar that has mostly black jelly beans and then just a few colored jelly beans. And the whole point of the image and the text that we have with it, the activities and everything, is to talk about how very little amount of the energy distribution in the universe is actually normal stuff like us. It's such a tiny amount, you know, and so much of it is what we can't see. And it's, you know, you have to use these really advanced telescopes like Chandra and Hubble and others to be able to detect that matter in very new and interesting ways. So the jelly bean universe is kind of fun. We actually ended up turning it into like a little hands-on activity. Very simple, very straightforward. We have kids or grown-ups sorting marbles and making their own little universe in a jelly bean jar. But it's really effective. You know, people really seem to like the fact that they're making their own universe in a jelly bean jar. I mean, that just sounds kind of fun. And, you know, it's hard to talk about those topics because it's pretty esoteric. But, you know, being able to do so in a visual way, I think, is really interesting for a lot of people.
Yeah, and of course those are some of the most fascinating topics to people, right? And the ones you kind of hear about, just, and maybe because they are so esoteric. But so the real challenge is, yeah, to take that fascinating, you know, wild stuff and somehow create some sort of, you know, yeah, something you can touch, something you can actually more concretely see in front of you and play around with, and get to understand it a little better. So,
my mother only likes the black jelly beans, so.
Oh, see, I hate those. I don't like
my
those.
mother be like, "Here." All the dark matter, but yeah, I see that at the Chandra booth at conferences all the time. I love
Yes, exactly, yeah. Well, it's been popular, so we figure, you know, if it's not broken, don't fix it, that sort of thing, you know. But people seem to like it. And you know, Chandra talks about, I mean, we talk about a lot of different aspects of that. We can talk about supernova remnants, you know, being in that small bucket of normal stuff. And then we can also talk about some of the more exciting physics stuff and dark matter, dark energy, and that sort of thing. So it's nice to be able to talk about the cosmology big picture as well as some of the more specific astrophysics results all in one tidy little activity centered around a jelly bean jar. So.
Very cool. So we are getting to the top of the hour. I would like to do a few announcements, and then I think Megan has given up on her internet. I think Kim will get a few last words from you on how people can find all this Chandra goodness. Today is Wednesday, which means our next hangout will be on Friday. Fraser Kane does the weekly space hangout. So that will be a bunch of us gathering around the good old hangout hearth, I guess, to discuss the this week's news in astronomy and space. Hopefully I'll actually make it this week. I've been so busy the last few Fridays. So yeah, that's the weekly space hangout, noon Pacific on Google Hangouts on Air, and check Fraser Kane's page for that, as well as CosmoQuest. On Sunday, assuming that, the West Coast, where a lot of our astronomers are centered, has been hit by clouds, so they've had to cancel like half the star parties in the last couple months. It's really sad. So hopefully they'll get going again. That's at 9 p.m. Pacific, so sorry East Coast, it's like super late, but most of the astronomers are over there. So that's the virtual star party. You can see all of these amazing things in the sky through other people's webcams, which is fantastic, or CCD imaging software. Monday is, looks like they've restarted Astronomy Cast at noon Pacific on Monday, so that's Pamela Gay and Fraser Kane doing an episode of Astronomy Cast live on air using Google Hangouts, and that brings us back around to Wednesday. And next week's Learning Space is...
So is it Dark Sky Rangers?
Oh my gosh, that's right. Yes, we had the hangout about... Yeah, so we'll be talking about Dark Sky Rangers and Globe at Night and possibly about the astrophotography contest that they're announcing the winners of that day and a whole bunch of other stuff because we found a bunch of cool
lot
stuff.
in that little cell. Okay.
Yeah, it started as Dark Sky. Oh yeah, you see the cell has expanded in the spreadsheet as a result of yesterday's meeting because they have so much good stuff to talk about. So that'll be next week's Learning Space, same time, same place. And I also I want to share another comment from Guido. It's the 15th anniversary for Chandra this year. It launched on July 23rd, 1999. So.
Yep, we'll actually be celebrating that. We're going to have a bunch of special releases, special podcasts, all sorts of fun stuff coming out from Chandra, some exhibits and that sort of thing. We're very excited to be at 15.
Very cool. You're 15. You can get your driver's permit. And
exactly.
I don't know if I want to telescope driving.
Yeah.
It's a fun image. That needs to be worked in somehow.
It does.
Kim, do you want to give any last thoughts, any last places where people can find all the cool work you guys are doing?
Well, definitely the Chandra website that I think I mentioned, chandra.si.edu. It's sort of our main activated hub, if you will, and we try to keep everything connected to that and feed out everything from that as our sort of main area of digital presence. But you can find us on Twitter and YouTube and soon to be Instagram, I hope, Facebook, and Vimeo, and a few other places.
I didn't know you guys were on Vimeo too. I gotta check that out.
Yeah, we are on Vimeo. I'm trying to think if I'm missing one. Pinterest, I think I mentioned. Yeah, so it's fun.
Very cool. Well, thank you so much for joining us.
Thanks for having me.
Thank you very much. Yeah.
Bye. Thank you everyone for watching.
Bye, everybody.
Okay. And we've lost someone.
I think we lost Megan.
Megan.
Oh, we did lose. Oh no.
Looked like she had bounced out and bounced back in, was trying to get back in, but we'll go on and introduce her. Oh, when she comes back in.
Coming back.
Hi everyone, welcome to this space. I am your co-host Nicole Gugliucci, postdoc with the CosmoQuest Citizen Science Project, and I'm joined by my co-host through the wall, Georgia Bracey.
Hello.
Literally through the wall.
Yes, actually, other side of the wall.
Other side of the wall. And we are joined by Kimberly Arkand from the Chandra X-Ray Center. Hello, Kimberly. And Megan. Megan, how do you pronounce your last name? Sorry. Having connection issues.
Okay.
Small core group of folks who work in the public engagement and communications section of what Chandra does, and kind of our whole methodology is to work really closely with the scientist whose result it is, and then work on being able to publicize and contextualize those results in a way that'll be meaningful for other people. So we're big into recycling because we don't have like a huge team to do lots of different kinds of work. So I think we kind of use like a pipeline methodology, if you will, where we'll get a new science result and we'll work on that. And Megan is a press officer, and she will, work with NASA to make sure the press release that goes out is great and it's, wonderful. And then it's up to us to figure out other ways to get that information, to reuse that information in ways that'll be useful. And the blog started up as a way to just be a little bit more. Being able to contextualize, I think, a little bit more, being able to put things there that are interesting but not necessarily a press release, maybe something about the telescope itself as a place to talk about the team members of the Chandra X-Ray Center and the work that the engineers and the software developers do. We've done things like highlighted different kinds of science and how it all relates back to Chandra. We've also looked at women in science and what their specific contributions are. So we kind of looked at the blog as a way to, bring all this different types of information to our audiences in a way that would be sort of interesting, that they could subscribe to, that they could comment on, that they could make. Sure. Thanks for having us. It's kind of fun to be doing this, something a little different. So my name is Kim, and I've been working for Chandra for about 16 years, I think, so it's been a while. And Chandra is really cool, as Nicole mentioned. It gets to look at really amazing things. So part of my job is just to help tell the stories about the Chandra science. Most of the work that I do is like a visual component, so I get to work on the process of image creation and then what to do with those images, which I think is really important. My background is pretty eclectic. I actually started out with my undergraduate work in biology. I was doing parasitology, so I was studying things really, really tiny. Then I moved into computer science, and then I eventually went to study public humanities as a way of figuring out how to communicate science topics.
Awesome.
Awesome. Very cool. Megan? Are you frozen?
I
believe she's frozen. Okay. So I guess she'll cycle out and try again. So I was drawn to the work you guys have been doing with the Chandra blog. Keeping up a blog is a significant task, I think, but it's a really great education and outreach tool. But you guys are using the blog and social media to put out so much amazing stuff. Can you talk a little bit about how the blog got started?
Sure, yeah. So we have kind of a...
Megan has a gorgeous outdoor spot that she's broadcasting from, but unfortunately outdoor spots don't always have good Wi-Fi.
Oh, yeah. It keeps kicking me off for some reason.
Yeah. Hi, Megan.
Hi, sorry about that.
Hello. So if you are watching, we'd like for you to participate by using the Q&A app. If you are watching this somewhere and there's a little Q&A app button wherever it's embedded in the YouTube videos embedded or on Google+, click that to join the Q&A app. You can send us questions, comments, hellos. We got a hello from Nancy Graziano. Yay! we're going to be seeing in about a week in Balticon, Baltimore for Balticon. So very excited. So we are here to talk some about different types of education and outreach coming out of the Chandra X-ray Center. For those of you who don't know, Chandra is a really super awesome X-ray telescope that is a satellite. It has to get away from the Earth's atmosphere because the atmosphere very helpfully protects us from X-ray radiation. However, that isn't helpful if you're an X-ray astronomer. So it has been, and it's one of the most gorgeous imaging space telescopes that we have, which is kind of a first for X-ray. We still joke with our X-ray astronomer friends about them counting photons or writing papers on one or two very energetic photons, but Chandra actually sends back some really gorgeous imagery in the X-ray. So I would first like to hear from both of you guys a little bit about you, what's your background, and then we'll get into some of the work. So Kimberly, do you want to start?